is surface area of different solids. And Monday we talked a little bit about which solids that we were going to find. So we talked about prisms already, where you know that there's two parallel bases to a prism. We talked about cylinders, where there's two parallel bases, but we're going to find the surface area of all of these. But today we're just going to do the prisms and cylinders. So I have some prisms and cylinders just to give you an example. So this is a prism, because it has the parallel bases. What kind of prism would this be?
Hexagonal.
Hexagonal. Okay, this is a prism. It would be what kind of prism?
Rectangular.
Yeah.
Just say a rectangular, because unless you know for sure it's a square,
Square prism.
just say rectangular. And this one?
Triangle.
Okay, so this is a triangular prism. So these are prisms, and we're going to find the surface area of these figures, and maybe the base could be a pentagon or an octagon or any of the shapes that we've talked about so far. So if you can find the surface area, or if you can find the area of a hexagon or a pentagon or any of those shapes, then you'll be, this section will be easy. Okay, so my next question is this something that you can ever use
Yes.
in real life
Yes.
if you're a builder?
Architect.
Okay, so give me a example. If you're a builder, why would you need surface area?
You can try and find a
Building.
tiling.
Building a light pole. So you're building a
A
column.
tiling.
Building a light pole.
No, not a light pole, like one of those power lines, because they're like. I know what you mean.
Okay.
How about
Like if you need to
Yeah,
put
redoing
columns
the
in.
floor.
How about if you're just
How about
building
tile?
a building?
How about
That
tiles?
works. Okay, what'd you say?
Tiles.
Like if you're putting tile on the floor? So when we think about surface area, we think more about a three-dimensional figure instead of just a one-dimensional figure. So painting a room would be a really good example of a way that you would use surface area. So basically, if you ever in your life plan on owning your own home or yard or vehicle, or there's lots of different ways that you can use surface area. I use it all the time, and it's not just because I'm a math teacher, it's because I own a home. And I have to do different things with that home that require me to figure out like how much paint to put on the walls.
Wait,
And-
must be proportional? I would just paint.
I thought you just started painting.
No, and here's why. Well, you have
That's what we did with my room.
to purchase the paint.
Okay.
And most of the time, the paint that you purchase, you have some certain shade that you want, some certain color that you want. If you go pick out a color on the side, you know that you go and they squirt little different colors in there to mix it to be a certain color, right? Well, the problem that I've had before is I went and got it mixed, and I painted one day and I didn't get finished. I ran out of paint, and then I went back the next day and there was a different person working. Well, I took him the exact same color and said, "This is what I want," but just because it was a different person, he made it a little bit differently. The shade was just a little bit different. So what I ended up having to do is repaint the whole room again to get it all the same. Because I could tell it was a little bit different. So what would have been a better idea is to make sure that I had enough paint to begin with and do the whole thing.
Now I get you.
So,
Alright.
I
you know,
thought you were
that,
talking about like just painting it.
I know, that's what I was like, with the walls, like,
Yeah.
how you, I
Yeah.
got it now though.
or like carpet on the floor, or a flower bed. You're making a flower bed, and you're, you know, a lot of people put mulch or pine straw on the on top of the flower bed. You would need to know how much to get, because that stuff comes in comes in bags, and each bag covers so many square feet. So this is stuff that you can actually use and will actually use at some point in your life. Okay, so we're going to start with this rectangular prism, and this is the formula, and this is important. So the formula is 2B plus pH, and the important part of this formula is that this B doesn't just stand for the base. It stands for the area of the base. And the difference is a capital letter. So when you see that capital B, that doesn't mean just one measure, it means the area of a certain figure. And the capital P stands for the perimeter of the base, okay?
So at S equals 64 meters squared.
I don't know yet.
Whoa.
Sure what you're talking about.
Wait, we have a different problem. Or I have a different problem.
You might be on the wrong
What
notes.
are you doing?
It's 11.2. Yeah, you're on the wrong ones.
Okay.
11.2. All right, so we're going to work out this problem, and then I'm going to explain why this formula works. So I just put the base here, and remember that the bases will just be two sides that are parallel. Well, if it's a rectangular prism, there's more than just two sides that are parallel. You could use these sides as the base. You could use these sides as the base. These sides as the base. So it's more than just two sides, right? So that means it doesn't matter what you use for the base, as long as you use that one measure that you haven't used already as the height. So I'm just going to use the bottom as the base here.
So this would be 50 inches.
So I'm going to draw it over here just so you can see it. We're going to let that be the base. So it's going to be 2. And what is the area of that base?
50 inches squared.
And what is the perimeter of this base?
30.
And then there's one number that we haven't used yet in the problem,
6.
and that's the height. So we get 100 plus 180, which is
280.
280. Okay, so now, is there a way to do this particular problem without a formula at all? Maybe what you would have done back in 4th or 5th or 6th grade?
Yeah.
What would you have done with that kind of problem?
10 by 5 times 2, 6 by 5 times 2.
Okay, so you would have found the area at the bottom, and the top, and the sides, and the front and back, and added them up, right? And that certainly works. But the thing that's good about this formula is it works on any shape, and it'll make it easier. Yes?
How is inches squared?
Because it's area. It's just the area of each side added up.
Right, to find perimeter.
But we use perimeter to find the surface area.
Okay.
I'll show you mine in just a second. All right, so let's look at a couple more examples before I go into why the formula works. So on this shape, what shape are the bases?
Rectangular. Or,
Or it could be triangle.
Oh, bases, yeah.
Because they're parallel. They don't have, like, the rectangles aren't
Bases,
parallel.
the only thing that makes it
The
a triangle.
triangle.
Right, it has to be the triangle because the bases have to be parallel. So that's another problem like that tent thing that I showed you. It's like this figure. Like
Is that
this.
what we're supposed to make a next? The next?
Mhm.
Alright, that makes
So it's the sides that are parallel. So there's only two sides on this that are parallel, and that's the triangles. Okay, so what kind of triangle?
Equilateral.
Okay, so it's equilateral triangle. So we're going to use our same formula. Okay, but the base is different on this particular problem, so the way we find the area of it will be different. So what's the easiest way to find the area of an equilateral triangle?
Side square root 3 over.
Very good. Okay, and the sides are 7, so that equals 49 root 3 over 4. And we're going to leave it just like that for now.
Oh.
And then we can plug in here. And what is the perimeter of the base?
21,
And the height?
5.
Okay, so the height, remember the height is always a value that connects the bases. It doesn't have to go up, it doesn't have to go vertically. The height can go either way, it just has to connect the bases. Okay, so just always look at it as something that connects the bases.
So it is,
It's
it's 5.
the height is
All right, so, you can plug this all in your calculator for this step, or we can simplify a little bit. We can cross cancel here. 49 divided by 2 is 24.5. And 21 times 5 is 105. And you can plug it in your calculator.
Wait, could you just add it?
Then you can add it in your calculator.
129.5 root 3.
Oh, no, you can't add that because the 105 is not multiplied by the square root of 3. Only the 24.5 is. So you would have to do 24.5 root 3 plus 105.
And that's the answer?
Mm-hmm.
Okay.
Or whatever that equals is the answer.
Whoa.
147.4.
I don't get how we did that.
Which part?
Is it because we multiplied by the root 3? Like,
This part?
yeah. Like, I would think that 24.5 root 3 plus 105 would be the answer.
It depends on how the directions tell you to leave your answer. But if it says round off to the nearest tenth, then you would plug it in your calculator and round it off. Okay? One more. All right, you get that one? Everybody understand that one? All right, we're going to do one more. And it is a pentagonal base, and this is probably the hardest one.
Is that a regular number?
No.
It's not
Yeah, it
regular.
is regular. Yes, it is regular. Yes, and you would need to know that. Okay, so same formula.
Sine squared root 3 over 4.
So the hard part here comes from finding the area of the base. So how do you find the area of a base if the base is a regular pentagon?
Two.
You can use the triangle formula, then multiply by
Trig.
5.
You could.
What would you do if you-
And then you size.
45, 90, 63.
Yeah, but it would not make a special right triangle. That's the problem. So
Do trig.
1/2 apothem times perimeter.
Oh,
That's what I was trying to
Yeah,
say.
that's what I was thinking.
So that's what we need to do.
Why
It's
is it
not gonna
not
work
working?
if we just, yeah.
All right, so draw the triangle.
Forgot what it was called.
Here I was thinking we're done because
We need this angle. So how can we get this angle?
36.
It is 36. How'd you get that?
360 divided
360
by
divided by 5.
5 divided by 2.
Thank you, Jenna.
Thanks, Christian.
All right, so we need, this is 2.5. This is the apothem. So we're going to have to use a trig function. Which one?
Cosine. Yeah, and tangent. Yeah.
Okay, so tangent of 36 equals opposite over adjacent. So switch. So apothem equals 2.5 over 10 of 36. Okay, so we're going to leave it like that. So we get the area of the base equals 1/2 2.5 divided by tangent of 36 times perimeter. So what is the perimeter? 25, because it's 5 times 5. Okay, so then we're going to plug into this formula.
Okay,
So that half cancels out.
So we got 2. The area of the base is here.
2, 1/2. 2. So couldn't we just take out the 1/2?
Yeah.
We're going to cancel it out.
Alright.
Okay, so 2b, all of this is b, plus ph. So p is 25. H is what?
11.
These plenty stacked up.
All right, so we can cancel this out.